Ricardo Iván Rodríguez Ramírez y vamos a escuchar el tópico titulado Synthesis, Characterization and Evaluation of Zinc-based Catalytic Reactions of Environmental Concern. Adelante, Ricardo.
Well, thank you for the presentation. For motives of these seminars, I'm going to talk in English. So, this talk will be divided in these sections. First, I will give a brief introduction about the problematics and the situation of the world right now. Also, I'm going to profundize in our hypothesis, why this will work, or the hypothesis that we want to test. Also, I want to give my objectives. Also, the method that we will be following, a brief summary of this presentation, and the work for next term. So, first of all, it's important to say that right now in the world, around 95% of the energy is produced by burning oil, almost crude oil. The rest of it is transformed and distilled into gasoline. Gasoline is used as fuel to propulse our automobiles, and obviously this will generate certain kind of gases. These gases are mainly greenhouse gases and also are toxic gases. For example, the NOx and the SOx are toxic. Also, ozone is really reactive and really oxidant, so it's also dangerous. Also, we got the emission of carbon dioxide and water. These gases are a real problem because mainly 91% of premature deaths are caused by these, indirectly or indirectly by these gases. This means that they are something that we need to take care of. Also, it's important to say that Mexico is the third place in emissions worldwide, with around this quantity of kilotons per year of carbon dioxide. The problem with these gases is that we produce them. When we inhale and we exhale, we produce also carbon dioxide. So this is one of the most abundant gases right now in our atmosphere. So the problem is that these anthropogenic sources, emissions, can't return to the original environmental cycle. And this will lead us to an eventual catastrophe. So to prevent this, we need to turn our heads to renewable energy or clean energies. Also, we need to reduce the pollutants that are right now in our world, and this will lead us to a sustainable development. If you don't believe me, this is the graph that showed how carbon dioxide has been concentrating in the atmosphere. We are right here. So yeah, I think it's prevalent. Also, we got the concentration of carbon dioxide in the last 50 years. So we have been emitting a lot of carbon dioxide. So it's a gas that we need to take care of right now. So to approach to our objectives, we need to evaluate how sustainability is achieved. First of all, we need to fulfill the demands of three pillars. There are mainly the environmental, the economic, and the social pillars. This means that we need to solve environmental problems, getting money, and having an acceptance from the society where this technology will be applied. So it's important also to prevent waste and prevent more emissions that those that we are going to take care of. So we need to follow the 12 principles of green chemistry, that they have the objectives to make chemistry more environmental friendly. This is mainly to prevent waste, to reduce the problems that we got in the laboratory, and to increase yields in our reactions and in our productions. So to achieve this, to remove carbon dioxide being greener, we need to return to the state of the art of carbon dioxide capture. In here we got several materials that have already been used in a really diverse range of temperatures with a lot of different capabilities of carbon dioxide assimilation or absorption. In here we got, for example, calcium dioxide that is really good for high temperatures. We got also the hybrid materials with organic, inorganic materials like metal organic materials, also mechanical hybrids, not really real mixtures. Also we got the zeolites that have a really good sortability, especially of water. Also we got carbon activated carbons and the laminar materials, the lamellar ceramic. In here we got, for example, hydrotalcites that are mainly cationic cationic lattices or cationic lattices with certain anions in between them. Also, we got, for example, in here the lithium zirconate that has been already used to capture CO2. That is an anionic. They are anionic layers with cations in the interlayer. This schema was reported by Choi et al. and Chen Susem in the 2009. It's important to say that the material that I'm going to introduce in this talk has this structure. So structurally talking, this can be a really good CO2 capture material. So as the title said, I'm going to use zinc as my main resource. But why zinc? First of all, zinc has this electronic configuration. Why is this important? Because when it forms the cation, it will have this electronic configuration. This means that we can have an sp3 hybridation of the atomic orbitals, having a tetragonal type coordination. This means that all the bonds that they will be making will be carbon-like, and we can have a lot of structures of different compositions of zinc and other elements of the periodic table. Also, it has an amphoteric oxide. Zinc oxide can react with either acids or bases. This means that when we react zinc oxide with, for example, acids, it will form superacid compounds. And when we mix zinc oxide with a base, we can have a really basic material. So this will be important for the sake of this presentation. Also, it's important to say that zinc is really a really abundant element. It's around 0.01 of the Earth's crust composition. It has also a really important production here in Mexico. We have the 7th place of production of zinc metal and zinc minerals in worldwide. This means that if we use zinc compounds and this becomes a mass production product, we can have a really good economic support. That means that we will be solving the first pillar of sustainability. Also, it has low toxicity. It's almost in the soup because it's used as, for example, microbiological prevention, also for cosmetics, and well, this will help us also to fulfill the social pillar of sustainability. We also have versatile usage. This means that we can catalyze a lot of reactions using compounds derived from zinc. This means that we can also fulfill the environmental pillar of sustainability, making a compound made from zinc, a ceramic made from zinc, a sustainable material. So, why zincates? I told before that we were going to make react zinc oxide with a base, in this case will be sodium hydroxide, to make a compound called zincate. Zincate has not been new in our history for certain years, because it's already a consolidated reagent in the plating processes in the metal and iron industry. So they use this ion, then they make react zinc oxide with sodium hydroxide to produce this ion and use it as a super basic compound. But no solid ceramic compound has been isolated from this ion, so it has not a specific application as a ceramic material. Being only 21 reference available on web, Science 1940, that report neither synthesis or existence of this material. This means that this ceramic phase is somewhat difficult to produce and therefore to report in science. Nevertheless, it has really interesting properties. That's why we are interested in this material, because it's, as I said, highly basic and also has the structure that will let us capture carbon dioxide. And therefore, it can be used as a multifunctional material. In here, I show you the simulation of the structure of zincate, of sodium zincate. In here, we can see that it fulfills all the demands that the previous chart that I showed asked for us to produce a really good CO2 capture. We can see here that we have the anionic layer with the cations, the sodium cations in between the layers. So our hypothesis is that the synthesis of sodium zincate with alkaline features can catalyze heterogenic basic reactions, including CO2 capture and transesterification processes. This means that this could also be a viable heterogeneous catalyst in transesterification. It means biodiesel producer, biodiesel synthesis. While CO2 and methanol respectively possess absorptive properties similar as oxygen, these will have really good. These compounds will have a really good affinity with the zinc compound that we will be producing. This means that there are also certain synthesis routes that we can fulfill using carbon dioxide and methanol as reactants. Our objectives to fulfill this hypothesis, to approach to this hypothesis, is first to synthesize the zinc salt and produce a pure phase, to improve sustainability and performance of this procedure. Also, we want to characterize these materials produced, and we want to evaluate them in some reactions that proposed. This is to fulfill this general objective, that is to synthesize this zinc-based material, to approach sustainable material, to evaluate it in these reactions. So the method that we'll be following, first of all, is the solid-state method. This is a really versatile method because we only mix the precursors, the powders, in a mortar, and we heat it to 600 degrees Celsius to produce only our material and a generally volatile subcompound or residue. But because we want to remove carbon dioxide, we want to prevent generating carbon dioxide, and this is why we are going to follow also a wet method. This method is really interesting. In here I show a brief video where I mix sodium hydroxide with zinc chloride, producing zinc oxide in situ, and reacting with the same sodium hydroxide that I added, producing a clear solution. It will be appearing briefly. It will be coming right now in here. In here, it's already produced a zincate ion. This zincate ion can be isolated by a certain treatment, producing sodium hydroxyzincate. So I show you in here the sodium hydroxyzincate already synthesized, and also this bluish compound. This was after giving it heating treatment at 400 degrees Celsius, more or less, producing the sodium zincate. So right now we have both the hydroxyzincate and the sodium zincate salts. If you don't believe me, I'll show you here the diffractogram of these materials. Here we can see that the hydroxyzincate, the sodium hydroxyzincate, is the predominant phase in this diffractogram, having also zinc oxide, because I was a little bit careless in the synthesis, and also sodium carbonate. This means that it's low temperatures we're having sortive properties of CO2. So, in summary of this presentation, during this term, the first synthesis attempts we carried out were successful, and also we started the characterization of these compounds. We also, according to literature, we can optimize this process by microwave assistance or IR heating procedures. Also, we want to increase the green aspect of this synthesis and this project, so we need to approach in this sense. Also, according to state of the art, zincates could be adequate catalysts of carbon dioxide and transesterification processes due to the basicity and chemical affinity of this material. It's important to say that the basic characteristics of this material can permit us to produce, to make a multifunctional material. So it's important to say this, because this can be used in a lot of procedures, a lot of synthesis. So the work that we'll be doing next semester are to purify this material. We want to increase the sustainability of the synthesis of this material. We want to continue to characterize the pure phase obtained, and we want to start to evaluate it in the catalysis of CO2 and transesterification reaction. This is my program of activities. First of all, I want to make a bibliographic research. Also, we have already synthesized the material, so we are in time in this aspect. We want to characterize these materials. We want to make the catalytic tests. We want to develop the thesis, and also to write and submit an article. So that will be all for me. I show you here a bit of bibliography that I read to the production of this project. I want to highlight this bibliography because was the last zincates wet synthesis reported till now. It's from last century. So I think it's important for us to start evaluating this material. I want to acknowledge also Matea, that is the group where I work, also CONACYT, our sponsors. It's also to this project, the C project from the IPN, and also UPIITA, that is a group that students from this department are carrying out, and so I've already received some invitations from them, so thank you. And that will be all by my part.